The true power of generative AI isn't simply creating novel data, it's crafting controllable novelty. Early models could generate endless variations, but steering them was akin to shouting into the wind. The breakthrough lies in latent space disentanglement, transforming an opaque vector into a manipulable canvas. Imagine a high-dimensional coordinate system where each axis represents an independent, interpretable attribute, like hair color, age, or object orientation. This isn't an arbitrary decomposition. It's learned through architectural design and specific loss functions. For instance, variational autoencoders can be augmented with beta VAEs, pushing the model to learn a more factorized latent representation by penalizing deviations from a unit Gaussian prior. StyleGAN, a Python-powered architecture, epitomizes this control, introducing a separate mapping network and an intermediate W-space. This W-space, unlike the initial Z-vector, is inherently more disentangled, allowing precise manipulation of high-level attributes without cascading effects on others. In practical terms, this means designing virtual fashion models where you can independently adjust jawline, eye shape, and textile patterns, all without retraining, or generating synthetic data for autonomous driving, meticulously varying weather, time of day, and specific vehicle types to cover rare scenarios. Traditional generative models often forced a holistic change when attempting modification, requiring complex conditional inputs or post-hoc editing. Disentanglement offers a surgical approach, direct interpretable influence over the generated output at a semantic level, significantly boosting efficiency in creative and data augmentation workflows. However, true disentanglement remains a formidable challenge. Quantifying it is non-trivial. Metrics like mutual information gap (MIG) or DCI score attempt to measure independence, but often struggle with high-dimensional complex real-world datasets. Moreover, there's an inherent trade-off between reconstruction fidelity and the degree of disentanglement, a balance constantly being refined in Python deep learning frameworks. The future of generative AI isn't just about making stunning images or coherent text. It's about intelligent synthesis. It's about building models where we don't just ask, what can you generate, but can you generate a specific thing precisely as specified? This shift unlocks AI as a co-creative partner, a precise tool, not merely a random oracle.